Welcome to our channel. In previous video we already discussed about interior point and their definitions, and in today's video we will discuss interior of the sets and some results based on interior of the sets. Interior of a set. What do you mean by interior of a? Let XD be a metric space and A be any subset of capital X, then the set of all interior points of the set A is called interior set of the subset A. It is denoted by A interior, that is A interior is equal to X is belongs to capital A such that SRX is contained in A, where SRX is any open sphere centered at X with radius R. We can also write it as A interior is equal to X belongs to A such that X is an interior point of capital A. For example, let R be the set of real numbers, then RD is a usual metric space with metric D. Suppose X belongs to R, then there exists epsilon greater than 0 such that X minus epsilon, X plus epsilon is contained in R, that is sphere centered at X with radius epsilon is contained in R. This implies X is an interior point of capital R. This implies X is belongs to R interior but x is an arbitrary point of R. This implies R is contained in R interior. Equation number 1. We know that interior of the set is subset of itself. This implies R interior is contained in R. Equation number 2. From equation 1 and 2 we have R is equal to R interior. That is, interior of real numbers is equal to itself. Second, let A is equal to AB be any open subset of R. Let X is belongs to A is equal to AB. This implies X does not equal to A and X does not equal to B. Then there exists epsilon greater than 0 such that X minus epsilon, X plus epsilon is contained in AB. This implies X is an interior point of A is equal to AB. This implies X is belongs to A interior, that is open interval AB interior, but X is arbitrary. This implies interior of open interval is equal to open interval AB itself. Third, let R be the set of real numbers and A is equal to closed interval AB is any subset of R. Let X is belongs to capital A is equal to closed interval AB. If X is equal to A, then X minus epsilon does not belongs to closed interval AB, and if X equal to B, then X plus epsilon does not belongs to closed interval AB. So if either x is equal to a or x is equal to b, then x minus epsilon, x plus epsilon does not contain in closed interval AB. This implies x is equal to a and x is equal to b are not interior point of the set capital A is equal to closed interval AB. If x belongs to A is equal to closed interval AB such that x does not equal to A and x does not equal to B, then x minus epsilon, x plus epsilon is contained in closed interval AB. So x becomes the interior point of the set A is equal to closed interval AB. So we conclude that interior of closed interval AB is equal to open interval AB. Fourth, let n be the subset of R. Suppose x belongs to n, then x minus epsilon, x plus epsilon does not contain in n. This implies x is not a interior point of n, but x is arbitrary. Therefore, interior of n is equal to 5. So the interior of natural number is 5. Similarly, interior of integer, interior of rational number, interior of irrational number, all are empty sets. That is, Z interior is equal to 5, Q interior, interior of rational number is also equal to 5, interior of irrational number is also equal to 5. Now we shall prove some results based on interior of the set. Theorem: let XD be any metric space such that A and B are subsets of X. Then A intersection B interior is equal to A interior intersection B interior. It is given that XD be any metric space. A and B are the subsets of the metric space X. Then we have to prove that the interior of the intersection of the two subsets A and B is equal to the intersection of interior of these subsets. Let X is belongs to A intersection B interior. So by definition, of interior point, there exists a real number r greater than 0 such that X is belongs to SRX contained in A intersection B, where R is the real number. X is belongs to the sphere centered at X with radius R. This implies X is belongs to SRX contained in A and X is belongs to SRX contained in B. This implies X is belongs to A interior and X is belongs to B interior. This implies X is belongs to A interior intersection B interior. But X is an arbitrary point of A intersection B interior. This implies A intersection B interior is contained in A interior intersection B interior. Put it equation number 1. Conversely, suppose X is belongs to A interior intersection B interior. This implies X is belongs to A interior and X is belongs to B interior. So there exist real numbers R1, R2 greater than 0 such that X is belongs to sphere centered on X with radius R1 is contained in A and X is belongs to sphere centered on X with radius R2 is contained in B. Suppose R is equal to minimum of R1 and R2. This implies R is greater than 0 and sphere centered at X with radius R is contained in sphere centered at X with radius R1 and sphere centered at X with radius R is contained in sphere with radius R. This implies X is belongs to SRX contained in SR1X contained in A and X is belongs to SRX contained in SR2X contained in B. This implies X is belongs to SRX contained in A intersection B. This implies X is belongs to A intersection B interior. But X is an arbitrary point of A interior intersection B interior. This implies A interior intersection B interior is contained in A intersection B interior. Equation number 2. From equation 1 and 2, we have A interior intersection B interior is equal to A intersection B interior. Next theorem. Let XD be any metric space and AB are any two subsets of capital X, then A interior union B interior is contained in A union B interior. Also show that A interior union B interior does not equal to A union B interior. Proof. Let A and B are any two subsets of capital X, that is A contained in X and B is also contained in X. Let X is belongs to A interior union B interior. This implies either X is belongs to A interior or X is belongs to B interior. So there exist real numbers R1 R2 greater than 0 such that either X is belongs to S R1X contained in A or X is belongs to S R2X contained in B. This implies X belongs to S R1X contained in A is contained in A union B, or X belongs to S R2X contained in B is contained in A union B. This implies X is belongs to A union B interior, but X is an arbitrary point of A interior union B interior. This implies A interior union B interior is contained in A union B interior. Now we have to prove that A interior union B interior does not equal to A union B interior. Suppose A is equal to 1 2 and B is equal to 2 3. Then A interior is equal to interior of 1 2, which is equal to open interval 1 2, and B interior is equal to interior of closed interval 2 to 3 is equal to open interval 2 3. So A interior union B interior is equal to 1 2 union 2 3, which is equal to 1 3 minus 2. Equation number 1. Now A union B is equal to closed interval 1 2 union closed interval 2 3, which is equal to closed interval 1 2 3. This implies A union B interior is equal to closed interval 1 2 3 interior, which is equal to open interval 1 2 3. Equation number 2. From equation 1 and 2 we have A union B interior does not equal to A interior union B interior, but A interior union B interior is contained in A union B interior. Next theorem. Let XD be any metric space and A, B are subsets of capital X. If A contained in B, then A interior is contained in B interior. Let A, B are subsets of a metric space XD such that A is subset of B. Let X is belongs to A interior, then there exists a real number R greater than 0 such that X is belongs to sphere centered at X with radius R is contained in A, because by definition of interior point, this implies X is belongs to SRX contained in A, contained in B, because A is a subset of B. This implies X belongs to SRX contained in B. This implies X is belongs to B interior, but X is an arbitrary point of A interior. This implies A interior is contained in B interior. It is sufficient for today. In the next lecture, we will discuss about open sphere and open set of the metric space. So keep in touch, watch our videos and subscribe our channel for more and more videos on these topics. Thanks to all. Have a nice day. Bye bye.